Okay, so now here's a screen capture from the drone video somebody put up. I want to take note of the planters all piled up over here, all this load, and yet people are saying the planters caused a failure. We have the planters there. We have the gate that looks like it can open. I'm going to try to superimpose some of the thoughts over top of the plans. We go to the plans, so we're at the edge of the gate here. There's the pool. Come forward to the pool and over this way, and there's a step down there, right? All right, so we come, let's confirm where we are. Here's the pool, lobby level. In this video, I'm also going to show the tie-in of the deck into the existing structure. It's not freestanding. I'm at page 234. Page 234, let's go with elevations first. Yeah, elevation right here. 11 foot 10. So let me write that 234, 11 foot 10 inches. All right. Inside this side of the inside the structure, we have an elevation of 13.4 over here, and it appears that it's the area at 13.4. So there's a significant step up. Over here is a pad that steps up. This is 12 foot 9. Where you step onto this landing. The landing correlates to. All right, so first off, let's do this then. We see 3 columns. 1, 2, 3. This from here to here is about 1 foot 6, I think. And that will be there too. That's important. The landing is over, this step up is back here. Let's see if I can move over a little bit. Turn around and get you guys to see. So there's the consolidation of these pots right here. And looking at the image again, you see there's a consolidation of all these pots, and right there, this is in front of that pot. So there's the gate, there's in front of the pot, there's the one palm tree that's down. This one is already removed by that time. So is that. There's a tree, and there's a step up, step around. There's that step up to 12 foot 9, somewhere about here, somewhere about in here, somewhere you step to 12 foot 9. This is the bump out. See the doorway? See the doors here? The doors there represent the music group. The doors represent, oh great, I'm trying to move over, okay. Got to move to the end of the structure, over to the right. So the doors would be, I believe, right here where you come out the doorway. And out to this structure here, this patio. It's a 7-foot patio. They put reinforcement. This is reinforcement. There's these BMA beams right here from here to here. Sorry about that. Let me try to move over. So there's the transfer beams. So we have a column here, right? And we have a no column here. How does it support itself? Well, there's a transfer beam from here to here. And then this rests on top of that, or side mounts into all built together. I think it rests on top of, or on top of it, but underneath of this one. There's another load-bearing type of wall built here, and this is goes on top of it. Whatever the hell this is. This is a deck of some type. There's 7 foot right there. There's your column, but now this is going to be beam 33. Here's BM 33 from here to here. Let me back down a little bit for you. Here's BM 35, but 33 goes from here to here. This is that porch bump out again. So here's a bump out. It's 4 foot. I think, well, the doorway's here then, I think. It's kind of difficult to here's a doorway. And I think there's a bump out and then a step back. I can't quite tell with the plane here. But it appears to be, as you can see, there's a doorways there. And on this side, I don't think this is the same plane. So let's verify that. I think it steps back. So you get that little bump out here, as in a camera there. A little bump out here, and then let's see if I can, and I don't see a bump out over here. So I see the little bump out right there, but I don't see the secondary bump out. Let's go back to the plans. So we're looking at this bump out here, and it continues over, opens up to a deck. Let's just jump right over here to the left now. You saw the 3 columns. Let me go out. Let me zoom out a little bit. So they're going to be substantial columns. Here's our pool, and substantial columns times 3 in a row. So you got 1, 2, shift. You got 1, 2, correction, hold the elevator. There we go. Where's our 3 columns? I am on the lobby level. You know what? I think I'll stick with this one for a second to show you my where the video where it gets a little funky. So this is the lobby level, right? And there's the existing building here. Everything past this plane here. These little J hooks represent that they do not cross over into the patio, which makes sense because the patio's height is 10 foot 10. Over here is 12.9 where they step out, and over here is another elevation that I don't know of. But inside the lobby area, elevation is 13 foot right here, 4 inches. So these two wouldn't meet a 10 foot 10 unless it's on a super incline, right? So that's not going to happen. So remember, this is below deck. There's a beam, transfer beam here. It's internal. Hold on. All right, this 210 is the one I find amazing. This is the one that got me last time. I just wanted to see if I can confuse you on purpose to show you the same problem I ran into the first video I attempted on this. So it looks like this front facing goes all the way over to here, to the elevator. So keep track of this, page 210. Now I'm going to slip over to page 217. And now, on 217, there's a pool. Here's my 3 columns, substantial columns. See the size? Oh, they're equal in size. 1, 2, 3. My elevation now is, so 210. Let me look at my notes here. This is page 217. My elevation now reads 12 foot, 0 inches. I went from 1110 to 12 foot, 0 inches. So there's right there, 12 foot, 0 inches. Page 210 says the elevation is 10 foot 10. Over here, and slide over to the right a little bit. So here's the pool. Right here is that pool. There's 1010. My elevation, come on. In front of the pool is 1212. So 1010's over here. 1010, right? Yeah, 1010's over here. So that represents the pitch of the deck. Remember the deck pitch that we were talking, that I said exists? So there's a deck pitch into the drain systems there. So that resolves the deck pitch. It exists. Now let's go to the, let's zoom, let's go back to 217 because you'll see the columns more clearly. 1, 2, 3. See how substantial they are? 1, 2, 3. Now let's go to here and look under, let me slide down. Just a bump over, and 1, 2, 3. All right, and that's holding this structure up that's still existing. I think this is 1 foot 6 when they reference it on there. So let's go back to 217. This is 217 up top here, lobby floor, 1, 2, 3. And then these are the puncture ones that the deck collapses around, puncture around these guys here. All right. So then we transfer to the structure itself. We need to make it over to the structure. I'm zooming in. So here's your bump out with the doorway there. These angles represent reinforcement, rebar. As you can see, they don't cross over. They tie into right here. This ties in here. Let's go to page 239. Page 239. So we're at the same place. There's a swimming pool. There's your big three. 1, 2, and 3. And then there's a bump out here. There's a column diagonal across it. We go back to 217. There's the column diagonal across it, and then there's the corner, the corner, inside corner there. That's 217. Here's 234. I think, yeah, 234. All right. So 234, we now get a little bit confusing. Here's 1, 2, 3, and now this column is not present. In fact, now they show a reinforcement going across into the structure, the elevator over here. The column's not there in 234. So let's, and it's 12'9" there, 11'10" here, and there's the pool here. It's page 234. All right. So let's go back to 239, and let's work from there, because that's more what we see here. There's the corner, and then let's go away a little more, turn around, and look back in. So across from here is the corner, the building's face, and then the corner's there, and that's that span from here to here for the wall is this deck that we're looking at. And there's the deck. So then we go back to 234. So there's that column that supports the structure. You saw 1, 2, 3. They're pretty large, still existing. But down here is where we get this decking. We got puncture. Here's the pool that where the deck starts falling down. People would make the phone call and report it. And then they said it felt like an earthquake. So how do you get an earthquake if the deck just falls down? Well, you need some tugging on that wall to get one of these columns to fail. And I think it's way out here. Let's see, 1, 2, 3. I think it's either this one or it's this one. I think this is my bias one. My MOM is there. Okay, that's cool. So right here, I think this is my bias column that fails. It's sitting on top of a transfer beam right here. So this deck rips down. Okay, we know it rips down somewhere about this pool area. So right about to this pool area, a little past it, there's that we already did the videos on the bad seam there. So it rips out, pulls, tugs on the building, gets 7 minutes before the collapse, 7, 8 minutes before the collapse. Doing so, it pulls like the ledger. Remember I said it was tied into the wall, and I needed proof that it was tied into the wall and not sitting on a separate column. Well, here's the proof. Here's the columns for the building. So the columns for this building, right here, the columns integral with some maybe masonry to make it wider. Right there are 16 by 16s roughly columns, and then they masonried it out, make it wider, or used stucco or whatever they did to make it a little bit wider. But this is the column detail. The tying into that wall system. All right, so this is where it gets freaky again, because we're on page 234, and I did a video saying, wait a minute, it just goes over here, and that's video just a retake, because I thought I was on crack for a second there, because next thing I know, I thought it was late night and I was getting dizzy, because next thing I know, I'm going to the next page, and I don't see it tying in over here anymore. See, this wall doesn't go all the way to there, unless you go to drawing 234. 234, it presents like it goes all the way over. This is the floor tying in, going all the way over the floor, tying in over there, and tying into the elevator shaft. That's the floor. Not on our side, on that side. On our side, the floor does tie in, but there's an interruption. There's a column right here. So keep note of this. So the rebar works by, so 8 number 4s. The 4 would be each eighth of an inch equals a number 1. A 1. So 8 eighths are 1 full inch. 8 eighths are 1 full inch. So 11 number 4s. So that would be 4 eighths, which is half an inch. This is then he does the numbers a little different here. He says number 4, which is half inch, at 10 inch. and I believe that's 10" on center, tying into this existing wall here, this elevation, whatever it is. And this is beam 38. You find beams that you find the beams. We'll go back to this 230 because this one is kind of confusing because it goes way over. So let's go back to what this one is, where there's a column. So there's a column there, and let's tie in this patio here. Remember, this is the large column. There's the deck that failed right about here that we can't just cover with material here, but we're going to assume that it tugged on that wall because the wall collapsed. So we get it pulling off like a ledger, a puncture happening, and it tugs on this wall here, and it shares, the deck shares that beam or wall. Well, here's how it shares. You can see right here that this says number 5, which is 5/8, 12" on center. You run the rebar like on an angle, tying in to either the floor, which is kind of odd. It would be the floor because the floor elevation on this side is significantly higher. It is at 13 feet 6 inches. Great. Just punch me in the face, why don't you? 13 feet 6 inches. Why do I say punch me in the face? Because over here, we'll get inside that room, and 13.6. Where's my 13.4? 13.6. That's what happens when you're on crack. Let's see. There's my 13.4. So there's 13.4. So they put a 2-inch pitch on the floor inside here. This is beam 34. All right, here's beam 33. So they're different design, but beam 33 is inside that outer wall with that bump out. See the bump out? The transfer beams. So there's a transfer beam, BMA, and then here's another one that goes across from here to this column. And then they load on top of that another transfer beam that goes, I believe, goes back and ties into either this is a column right here, which I don't think it is, or it ties right on top of this BM33. Beam 33 is massive. BM33 right here is the bottom of beam. See, elevation, bottom of concrete. The bottom of it, so the clearance in the garage area, if you will, would be 9'10". So you can get a car underneath of that beam. And the sizing is 24 inches wide by 42 inches deep. All right, so that's pretty huge. All right, so that's the breadth, the depth. It's 42 inches deep. That's a rebar configuration. And so 24 by 42 inches. It is one hell of a huge beam, this number 33. It's going to take a lot of load. Transfer, and so you're getting it this right here, and it's not on the ground. It's 9'10" off the ground. It's sitting on top of these piers on these columns here, and these are 16 by 16s. The tying in of our deck. Let's close this door a little bit. So here's the floor inside the building, tying into that wall, into the floor, tying in. It ties into the floor here. My problem is it doesn't show as a beam here. This is the floor is tying into, and the floor tying into here. This does not identify as a beam. It does not identify as a beam. I'm making fun. Here's 1'6", and that 1'6" is a weird thing because remember I pointed. Here's 1'6". Where's my other 1'6"? There's a 1'6" overhang. Identified. Okay, you can run me around. From the face of this column to out here, I believe is 1'6". This is also 1'6", which is a weird thing. So here's our columns that the floors tie into as they work their way up, and you can see this will be a floor. It's a J bar terminating there at that level, at this elevation. The elevation per the closest elevation I could find. I'm trying to zoom out. The closest elevation I could find on this floor over here is to the right. I'm just verifying. I don't see another elevation. It's 13'4" right here in this elevation, and over here also. Remember, we got a conflict. We got a 13.6 also, which is opening the page up, a 13.6 over here. And on this side, it's also 13.6. So we have a conflict here, 13.6 and 13.6. So then we go look at dates, right? We come down to the bottom right and we look at dates of the plans, see which one's the latest. This says 11/6/79. This one's 13.4, so 11/6, right? We scroll over. This one says 8/22/79. So August 22. And this one says 11/6/79. So then this will be the latest version. So we grab the latest version of this and we go over and say we'll work with the latest version and say the latest version says it's 13.6. So we'll cancel out the 1 and we go to the reinforcement here and we see this column at it. Now let's close the door on that. So 13.4. So remember this detail here, how this went over. And it's the same floor. So we go to the dates and you see this was 8/22. So this may have been, this is all the drawings, as people say, they get confusing. So that's his 8/22. Now we bump forward in time and we see here there was a transfer beam at one time and they appear to be smaller. Where's the pool? There were transfer beams over here. Oh, at that time they had a transfer beam here. They had a 10'10" elevation. They had the building stopping back here. Transfer beam, and I don't know what it's loading. It's a different configuration. A beam and then a tie-in. It looks like a bump out over here in line with the building. And this was all, I think, open probably. So here's some different details here, but we can bounce out of these. And it's stated beam 33 is 12.9. So we'll go to the latest drawing again, which is 11. That's 8/22. So we'll bounce out of that one. And we go to the latest drawing, 11/6. Well, that's not the latest drawing, is it? That's not the latest drawing, is it? This is 11/6. 11/6. Okay. That's 11/6, 217, and 239. 11/6. I think I closed. I think this one is 8. Okay. So then we got two pages to do. 217. Okay. Let me make sure my notes. Let me keep track of this. So 11. So this is 11/6. 217 is 11/6. That's the latest version. And also page 239. So I'm just writing this down. Give me a second so I don't get lost in translation with you guys. So we go to verify first elevations on the deck. So I look for elevations on deck. I don't see any on this one besides over here. It says 12-foot elevation. So we go to, that's 239 right here. So we go to page 217. We look at the pool. We see the pool and we look for elevations again. And this says 12 feet. Elevation is 12 feet here. So 217 and 239. 12 feet. So elevations are matching up. Look at the reinforcements here. We just try to see what changed, but if anything at all. Here is how they tie into the deck, the pool deck. They tie in with 5 number 12s, so 5/8 number 12s typical, as page 2 set through 39, and oops, and 217. You can see the same thing happen there. Same thing again. 5 number 12s. We go to the image, And we see, well, somebody forgot to put the reinforcement in over there from all the way over. The pool is a little different configuration, but nevertheless, the intent was to have the reinforcement. And there's also a hot tub there. But we have 1110 out here now. So we got 12 foot over here. Where's the elevation over here? We got 1110 here. Page 230. Oops, I'm at 234. 234 is the wrong date. So I want to save this for later. So 239 and 217. Okay. So we got 12. Our elevations match up. So now let's match up our columns on that, on the zooming out. Let's match up our three large columns. There they are, 1, 2, 3. It's page 217, and then you jog over and you run to the corner of the structure. Okay, so let's do that. That's 217. Let's look at 239. We got 1, 2, 3. Zooming out. 1, 2, 3, jog over, there's the structure. It says you have, zooming in, there's that 1'6" I talked to you about right there. So that's that 1'6" offset center line of that column is where it now comes into play. So not the face out of there, but center line of the face of this column apparently to the center line of this, center line of these columns. So that would be the center line of this to the center line of a column that we can't see. So 1, 2, 3, and the column, it should be somewhere in there. I see a light. That's a waste of energy. I'm not going to be able to find it that way. Let's go back to 217, and now let's tie the floor in. So the floor is, you saw the elevation, 12 foot. Elevation in here, we're going to keep it at this elevation they offer, which is 13.6. All the way around here, and here's 13.6. So we're tying into, yeah, this one did. Here it is right here. This says 5 number 12s, and the beam stops here. Let's look where the beam stops. And this is a floor. But remember, floors, they like using J-bar in the floors, but this they turn this one just L-shaped. So it's the floor from there tying into tying into the beam here. Over here, tying in from the floor, tying into the beam. On this side, there might be a step down from the floor tying into the beam here. So it would look like the beams take side loading twice. The floor for in here at 13.6, and on this side at 12 foot 9 over here. It's 12 foot 9 over here, and 12 foot here is existing. So I don't know if it made it up 9 inches from there to here, because remember this thing has a pitch on it. So 9 inches, you know, runs a nice water runoff from there to there, and that would be that what they would show that in the other drawings. Here's a tie-in from the pad. So remember, there's the column, there's the structure of the building, and this is how they tie that in there. There's 4 half-inch rebar, 4 of them, 4-inch on center. Hell if I know. This one says 5-inch rebar, 12-inch on center, going this direction, and this one says 5-inch rebar, 12-inch on center, going that direction. You would think it would go all the way over, but then we have some 4s over here. Number 4s. Yeah, don't know the configuration of that exactly. Structural detail, we're looking at them, it's not clear of that. So this one gets 5/8, 12-inch on center, and it ties in the pad to this structure, to the existing structure. So the pad failure would pull on the bottom of this, causing the rest of the building to be in cantilever, drop off, and fall away. So this pad was tied into these columns via its own floor pad interaction at a lower level, 12.9, and this is at a higher level at 12.6. So there was a step up, I believe, from the inside the building, from outside the building. the tie-in. I'm using 12.9 because I've found that over here is 12.9, and maybe I can find it here for you on inside here. Inside here, 12 foot right here, elevation 12.9. Now that is a deck area type deal, so that might be a one-off because there's a step over there too. There's a lot of transfer beams. So, and this is a later dated product. And over here, you can see that they did not have from here. There is no beam. There's no beam here on this August drawing. I believe this is August. Yeah, August 22nd. Fast forward 3 months, and you go from here to here. You get a different configuration on 217 of this bump out. An extra column. This made an extra room over here. Apparently, 3 months later, this structure got another room added. That extra room that we see with the wall missing in the images, going all stripped up by that with that little bit of a gap there, and looks like a stairwell right about here somewhere. So this gives them an entire extra room, more footage to use, all within 3 months that popped up. This ties in, and elevation is now, is it 12.9 or not? It ties into the wall there. You can see the floor ties into the cross this way, but more so my floor out here, where we get the collapse, ties in with to these beams in a floor capacity. So this concrete just, damn it. So collapse. Let me try collapse. Yeah, dolls. That didn't work. I have no idea where that was coming from. Collapse. Surfside. Images. So this is where that thing I'm talking about, that little this came forward and bumped out, and the floor capacity looks like it would be like that. Here's a column and here's a column, and it just ties into it, and then you run your flooring above it, your steel above it. The issue I have with this is that means they had to make 2 heads to make this floor tie in, and that floor. How did they tie into the side of it? But it shows it here that in this one on August they used 5 number 12s. They were tying into the structure, and that's 234. Yep, page 239. That this appears. They still tie into it, this direction and this direction with 5 number 12s. So here's the evidence now, is tying in this pad into right here, into the existing, and over here. There's space 12-inch on center all the way down, and it's the cross steel that's supposed to be there. This is the evidence now showing that the pad was tied into and connecting to the columns of the existing structure. It was not freestanding. The structure, the pads, the deck was not freestanding. So now you can go to that other building that you're worried about if it's going to collapse or not, and see if it's freestanding. If it's also connected in this format, well then that means that deck could do the same thing. A duplication could happen and cause a failure there. So that's where all this matters. Now, I believe it cracked here, butterflied the deck, and then went 2 directions. As it butterflied down, it punctured through these guys a little bit, cars, vehicles there, and then punctured through here. The loads are too much. Punctured through here, loads are too much. As it's dropping down, it tugs on these guys on the columns. As it tugs on the columns all the way over to here, this one experiences the worst tug of them all. This is M, I believe. So M gets the worst tug of it all, and that's when we see the video of it vibrates all the way up through the wall, earthquake style. It doesn't collapse. 8 minutes later, the structure up top is so strained, or down here is where we see it looks like it buckles. And then that starts the progressive collapse, where this gets a slight buckle, the top floor being of a weaker design. That is, we go to the columns, wrong direction, beams of a weaker design. The columns set up, these are columns, the column in saving value, dollars, they went from 6,000 to 5,000 to 4,000 psi. And when it rattled, that would be C, 16 by 16s. When it rattled, that top floor, the top floor from 7th up, being 8th floor up, being 4,000 psi, is weaker. The rebar is less, it's 4 by 8. It couldn't stay engaged enough, and that's what failed first. It took a bump down and ran into the 5,000 psi, which slowed it down just a slight bit, down to the 7th floor. And then we see the rest of the steel, just because it uses resistance, all the steel. And that's that slow deceleration, but nevertheless progressive full collapse down to grade, down to its current resting state. So I'm ending the video with, now we have data that shows it was connected to the building. So I'm happy for tonight, and have a good morning. Oh, please comment, because I need it for the algorithm. And please thumbs up. And I love it, love that you guys love the data. Take care.